Okay, to proceed with our discussion on the solids of revolution, or these are the solids that are generated by revolving a flat surface figure. I'll just explain the concept first. Let's say we consider this area between the x-axis and the curve. What happens if we rotate one axis of this figure? For example, if I rotate the x-axis, this axis, so if I rotate the x-axis, what would be the volume generated? Diba? So we could imagine this as, atong i-rotate ang x-axis dire, so this will generate,
So it will generate that solid. This whole area will generate this solid in this shape.
right? So I could draw that here for reference. So ito siya originally, then because of the rotation, it will generate this shape, the volume. Like that. So it's a solid in that shape. Diba? So what will happen if we rotate this axis? So if we rotate that axis, it would generate etong solid. Right? So ato na siya i-drawing or i-separate natin yung drawing. Just assume that they are the same. Etong tip that would rotate. Again, not drawn perfectly, but I'm trying to make this as accurate as possible. So the shape is like this, parang, saba, parang gulaman. So it would look like a solid na ganyan, no? Medyo ano siya dito, parang ang iyang hole is mura siya vortex dire ang kanyang hole. Then flat yung surface niya dito sa baba at the bottom. Okay? I hope you can imagine. Okay? And this volume could also be, if we apply integration, pwede natin gamitan ng either disk or cylindrical shell. Example, if we consider a vertical, practically, no, I think the most convenient strip na pwedeng gamitan is vertical, no? If we consider a vertical strip, it would be hard if we consider a horizontal strip because like based on what we have discussed kanina, it would be function minus function, right? The same function, isa lang kasi yung function natin. So if we, it would be more convenient if we consider a vertical strip. Okay? So if we are considering a vertical strip, it's like we are integrating the solid generated by each vertical strips, right? So therefore, eto siya, if we rotate this small strip here, it would look like this. So etong strip, it would generate a disk, right? Ito yung generate niya. So, you could imagine that mayroong mga disk dito in varying sizes that comprises this solid, right? So, na-imagine? So, yun yung solid of revolution. So, meaning, if we integrate all these disks, it will now comprise the whole solid. So, using this same disk, using this same strip, what happens if we rotate the y-axis or this axis? Ito yung iikot na axis. If that rotates, what will be the shape of the volume generated by this strip? Sige daw. So, if we rotate an axis perpendicular to the strip, the result is a disk, this one. Now, if rotate the axis parallel to the strip, and this is our axis, this is a strip. So, if the strip and the axis of rotation are parallel, the result is a shell, is a cylindrical shell. So, you can imagine that as because it's a differential thickness, nipis ni siya. So, what is generated is it's like a shell that is too thin, diba? Hindi siya solid, but it's just the surface around. Okay, so it would look like this. Okay, not drawn accurately. And that is just that shell. With thickness, ito siya, that is now dx. So that's our differential thickness. So therefore, you could imagine this whole shape as comprised or the integration of these shells. Na-imagine ninyo? You can liken this into a rolled paper, di ba? Kung mag-roll mo og paper, those are comprised of small shells. And if you integrate those small shells, the result is a solid. Okay? So, mo na to. To summarize this illustration for the solids of revolution, if the axis of rotation is perpendicular to the strip, the result is a no, the result is a disc. Or kung disc siya, kung meron siyang butas, it's called a washer, di ba? So that's a washer. And this is a cylindrical shell. If the axis of rotation is parallel to the strip, the result is a shell. Okay, so we have two approaches. Now, how do we get the the volume of this? Remember, in this particular function under this curve is we call this f of x. Okay, the volume of this disk is simply this area of the face multiplied by its thickness. So if you recall, for example, you have a box, length times width times height, volume, that is the same as getting the area of the base, diba? That is length times width multiplied by the height. So that's area times thickness or times height. So same as here, you just get this area and multiply it by its thickness. What you get is the volume. So therefore, if we call this our differential volume, the differential volume is just equal to the area, right? To the area times its thickness. So in this case, we have a circle. The area of a circle is pi r squared. So that's pi. What is our r? The radius. The radius, looking at the graph, that is just y. This is y because all coordinates here are x, y, right? So therefore, this is x and this is y. Paulit-ulit. So therefore, pi radius squared times the thickness, which is dx. So therefore, the volume is just the pi times the integral of y squared dx. So that would be the volume of this solid. How about the shell? What would be the differential volume here is this thin shell or thin cylinder. So how do we get the volume of this to represent to be our differential volume? So that is just simply remember the this is hollow, di ba? What comprises this differential volume is just a thin shell. Nasa labas lang, di ba? So that is just circumference times this. Okay, remember that this is equal to this, right? Okay, so therefore this is y gihapon. Now, that would be this circumference times y. This circumference times y. How do you get the circumference of a circle? So, the circumference of a circle is just 2 pi r, right? So, what is the radius of this? What's the radius of this? Okay. Since this point is xy, so therefore this is x, this is y, so therefore this is x. Okay, so therefore that is just circumference 2 pi radius times this. So what they are basically getting is just the surface. Ang surface lang siya. So times y times the thickness. Of course, we need to multiply the thickness of this sheet or this shell. And the thickness is dx. Then that would be our equation. So for cylindrical shell, the volume is just equal to 2 pi times the integral of xy dx. But of course, this equation depends on the situation. So what I illustrated here are the concept. No, so we for the sake of clarity, we'll just use any generalized equation, because if you just memorize equation without looking if the equation fits the situation, then you'll get the wrong answer gihapon. Okay. Yan. I just illustrated to you the different approach, either by cylindrical disc or cylindrical shell. Sorry, either by discs or cylindrical shells. Okay?